Hello there. I thought I'd write and record a little video just to demonstrate how we're going to go about extracting this information. Hopefully it'll be a little easier to see if you see me actually writing the code than just rather dully displayed on the page there. So we've headed over to our website where we've got the information. So we're on the Renewable UK's website, and some of the points to note here, we've got this table of operational wind farms which we want to extract. And the web page itself, as it's nicely laid out. We've got some table here, we've got some other page elements up here along the top, and we've got 13 columns in our table and an unknown number of rows. And it's unknown because it's dynamic, simply because new wind farms are going to be added to the list, and potentially old farms are going to be removed off when they're decommissioned. So we can't rely on there being a fixed number. It's not that there's always 100 elements to the table. There are a variable number, but we can handle that in the code. So main things to note here: this table on the web page, 13 columns, a variable number of rows, and it's a table amongst other elements on the page. So we'll fire up our Python shell and start writing some code. So I've already populated the shell here with some sort of basic information. We've got our main function here. We have two libraries, urllib2, which comes with Python, so you'll already have that. We have Beautiful Soup, which is an additional library which we need to install. There are links in the main page, main blog, and we have a little extra header at the top here to handle defining where the Python environment is in a Unix or Linux system. Windows doesn't necessarily need to have that installed, in fact doesn't, but we leave it in there for completeness. So we want our code to do a number of things. The first thing, of course, is to head over to the website and import the website data. So we'll use urllib2 to pull the website information into a new object. We'll then pass that object's data over to Beautiful Soup, which is a great library to handle the processing and scraping of website data. We'll process it a little bit in Beautiful Soup, so it knows what table and rows and so on and so forth are. So we'll use its built-in capacities there. We'll then need to pass all that table information, so the strings of that table, into a new object to handle just that table information. And then because that will essentially be a long a list, but just a long single element of data, we'll then want to write some bit of code which will go through that list and pull off the individual elements. So it will pull off, say, wind farm A and all its data, put that into its own element or an item. We'll then want to go through the next station, and so on and so forth. The reason for doing that is that it's going to make it a lot easier later on to handle and compare stations. So say, for example, we wanted to pass the information to a database, or we wanted to use a numerical library to say calculate the average of the capacities of all the wind farms in a particular location. It's much easier if you've got the wind farm data in its own discrete item of a list. So item A, wind farm A, item B, and all the associated data with B, C, and so on and so forth. So that'll require writing an extra function, but I'll show you when we get to that stage how to do that. So let's proceed. So the first thing I want to do is, obviously, I'm going to write some real time, so you'll see all my typos live to tape, as it were, up here. So we'll use the URL library, and we'll open up the web page. HTTP, we'll go on www.wwe. Now, obviously, if you're using this script, and you're more welcome to, of course, in your own code, and you're going to a different website, obviously you'd modify some of these details, the website being one, of course. So we pass into it the web address, and that's going to return an object called URL, which has all the data from the web page. We want to pass that into Beautiful Soup, so I'll just make a new object to handle that, called Beautiful Soup, and the object is called Soup, but calling Beautiful Soup, we'll pass the URL in,
and then Visual Soup knows what a table is and what a row and so forth are, because it can recognize the HTML tags that are in our web page. So we want to pull out the table, so we'll call it table extract for want of a better phrase, and soup.find all. Now we tell it to find all tables. Now I happen to know through prior inspection that the table we want is the second element, and of course in fact it's the third because the array starts with 0, 0, 1, 2, 3. So we just tell Beautiful Soup to go and find the second table in the web page, and then from that table pull out all the rows. So we'll just make another object called rows, and from table extract again find all, and we'll go rows. So the HTML tag for row is tr, table row, and that's about it for the HTML processing. Pretty simple. Now what we want to do is we're going to want to go through this rows and find all the individual elements, so each of those cells of that row. So to do that, we're going to create a liquid object to or list to hold them in. So I'll call it output wind for the sake of argument. And we also want to make it a quick incremental counter, because we're going to loop through a certain number each time. So that done, what we're going to do is for just call it rows. So while the length of the object, that is our extract, while x is less than the number of rows. So what we're going to do here is, because we don't know how many rows there's going to be in our data, maybe the stations get added, stations get removed. We're going to go through there and just until x is less than the number of rows. Then for each column, I want Beautiful Soup to find, again find all being our friend, each HTML element called TD. TD in HTML is the individual discrete cell, if you like, of each row, or each row and column. So we find each of those, and then for each columns, for D in columns, what we want to do is then say, okay, well, find the text of that element. So the text that corresponds to the date of commissioning, the station name, its coordinates, its capacity, and so on and so forth. So you can do that by just looping through again, and we want to pull out the text for those. So I'll make the text to join, and td find. Now, if we were certain that our cells only ever contained text and no web elements, so no HTML code, then this would be superfluous. We don't. Each of those cells is going to have some formatting data or extra HTML code, so we want to just strip off only the text, right? So only where the cell element is text, and then we'll just convert it to a string to be which we've done, and then we want to remove any blank spaces, because there may be some additional spaces either side of our text, so additional formatting and stuff. So that we'll use the strip to do that, and then we'll just append to the output object. So, and then we'll just increment our counter by 1. Finally, for this little section, I happen to know that the table element has 4 blank elements at the start, which we can get rid of. So I'll just do output wind, and then I'll delete off those elements, and that is almost all the way we need to be. Now if I ran this now, what we'd see, in fact I'll just do a quick demonstration and say for stuff in
do is, if I just run this now, what we'd find is just a long mass of text being extracted. So I just jump in, so you can see here it's all this stuff, right? And it's fine. It's got the information we wanted there. I've just got the top. We can see that there's the header of the table. Then you've got information here, which is okay. Now, yeah, okay, we got stuff out. We can do something more with it. So the more with it is to write a quick function to go through output wind and split off that data into groups of 13. Remember I said there were 13 columns. So we'll do that. We'll define it as pairs. It's pairs of data. And this little function, we'll pass it into a list. So I'll call that L. And we also want a number, i.e. the number of units which we want to split that text by. So I return zip. And if you don't know the zip library, it's just I strongly recommend you go and look it up. It's a fantastically powerful library, and I might do a video at some stage on it. But for now, just take it as read to sum up the function. So let's go from I to n. So that's how many elements. And then for I in range of n. And what this is going to do is then go through and split out our list into elements of 13 units long, 13 items long for each station. As simple as that. So let's take off this demonstration bit here, and then we'll say with that function now defined, let's go and use it. So I'll make all wind farms, just a new little object, equal to the pairs, and we'll pass into our list, which was output wind. And I give it, split it by 13 corresponding to the 13 columns. And now with this all wind farms, now I'm just going to write it so it prints off the list just for demonstration purposes, but obviously you might want to pass that list in something else, maybe a database or some numerical program, something like that. Or maybe you just want to print it off, save it as a text file, for example. So I'm just going to demonstrate those. So for wind farm, in all wind farms, print wind farm. So if I run that now, we'll see, I'll interrupt it of course again. Save that. Oh. That. Never run it again. You see, just interrupt it is. Now each wind farm, or each group, is its own nice little defined element. So look, there is our element table, and we start to refer to this in other stuff. Much more useful, much more powerful. But obviously you might want to write this off to what you want to do. So that hopefully demonstrates what we do. So in recap, we've set up a main function. We've imported two libraries, Beautiful Soup and urllib2. We've defined our source information and extracted it out of the table. We've made a new list to append this information to. We've gone back through our extract and found all of the individual cell elements within that table. We've done a little bit of data housekeeping on it. And then we've written a little quick another function which will take our list and split it into 13 chunks of 13. And then we've just displayed it for purposes of this video. Hopefully that explains it all. Any questions, send me an email, put something in the comments, and I'll get back to you as soon as I can. All right, thank you very much.